Use your graphing calculator to solve the equation graphically for all real solutions. X to the cubed minus 6x squared plus x plus 28 equals 0. Make sure your answers are accurate to at least 2 decimals. So here's what we need to do. In order to solve a polynomial using the calculator, we will draw the graph of it, and wherever solutions occur, so wherever this is equal to 0, is where the graph is going to cross the x-axis. So we're effectively just looking visually for places where this graph crosses the x-axis. So x cubed minus 6x squared plus x plus 28. When I graph this, if it happens to land on integer values, then that's great. Those are the solutions. But if they're non-integer values, then we have to go a little bit further to solve for them. This one might be at -2, but if you're not sure, there's a great way for the calculator to help you determine that. You hit the second and the trace button, which gives you the calc menu. It lets you do some calculations based off of functions in your y1, y2, and so forth. So let's find a 0. A 0 is where the graph crosses or touches the x-axis. So I can see a 0 here, which is approximately at -2. What the calculator is saying is, give me some bounds where this is happening. So a lower bound and an upper bound, and an initial guess as to where that's going to be. So it's definitely somewhere between -3 and 0. And our guess is that it's -2. So we'll see. And it turns out it wasn't at -2. It was close, but not quite. So I need to answer these with at least 2 decimal places of accuracy. So this first 0 should be -1.83. All right, the next one, just up the way here, there's probably 2 that are fairly close together. So what I'm going to do is I'm going to zoom in on that region. And the zoom I'm going to use is called zoom box, because what it allows me to do is just put my cursor at the corner of a rectangle. So that the viewing window will be replaced by this rectangle here. So I'm really getting a very zoomed in picture of what's happening at this place. All right, so I think I definitely see 2 different zeros here. And to figure out what they are, I need to calculate them. So second and trace, then 0. This bound, let's see, if that's 3.82, this is probably 3 and 5, I suppose. So let's give those as our bounds, 3 and 5. And then we'll guess at 4. Oh, okay, so this other 0 was actually at 4. Now, to figure out this one, it all comes down to where your initial guess is. So let's try this process again. So we'll again say from 3 to 5, but this time I'll give an initial guess of like 3.5, which is closer on this side to this one, so it should find this one first. There we go. So 3.83. So there are the 3 zeros accurate to 2 decimal places.